call wavelength, we have what we call energy. If I say energy, the rate at which work is being done. Share it. Now, it is being confirmed that the higher the wavelength of a wave, the lower the what? The energy. The energy is being experienced. That is why every human, share it, every human that is living around places or area being experienced by radio waves, they don't really have issues. Why? Because this particular radio waves has larger what? Wavelength, but shorter energy. You understand? Whether it's heat energy or any energy that is being experienced. But when you talk about gamma ray has what we call the shorter wavelength, but it has a very high energy. Meaning that gamma ray is not a ray that should be what? Joked with. Let's say, for instance, God forbid, you went to a medical professional and he wants to incident on you an X-ray, and he wants to incident a gamma ray. It will destroy the person's body system instantly. Person can just go blind, or you understand, you will start going mad. Do you get what I'm trying to say? So it means that your gamma ray is the most powerful of all. Uses of our electromagnetic wave, which I've almost explained it all. Our radio waves is used by TV and FM radio, direct line transmitter, medium wavelength. You understand? We've already spoken about that. Our infrared radiation, our infrared ray, our X-ray, our gamma ray, and those are the uses. So gravitational field. As a scientist or a physicist, anytime you hear field, it meant a lot. It goes beyond the normal field you've been listening to. When I say in terms of forces, it means that the force is the main, the forces being experienced is the major parameter, you understand, that allows field to come into place. Now, examples of field, we have what we call magnetic field, which we are still going to talk about it in this SS3 series. We have what we call gravitational, which we are already on it now. We have what we call electrical field. We also have what we call nanotechnological field. Now, this one is a new discovery. You understand? In fact, the beautiful thing about sciences is that so many things are actually being done that you see in books, so many things you read in books are very, very much practicable. You understand? You definitely see in your day-to-day life. Now, let's go back to what we're actually talking about now. What is a gravitational field? Gravitational field is a force field. Gravitational field is the force field that exists in the space around every mass or group of masses. Force field. Now, gravitational, English, let's break it down. Gravitational is a combination of gravity. Now, when I say gravitational, it has changed your gravity into another word. So we are combining gravity and what? Field. So I said, we gave definition of field the other time. We said it's the platform where parameters in terms of what? Forces. So if you now say gravity and field, it means that parameter that is being what spoken about is what we call gravity. It's just a place where what gravity is being experienced. You understand? It's just a point where gravity is actually being experienced. Now, what is gravity? From your what? SS1 physics, we spoke about tendency for any object, you understand, which goes vertically upward to what? Return back to its base. You understand? I don't want to know your discovery. I don't want to know your level of powers. You understand? Anything that goes up, any object that goes up must always return. As long as you are on planet Earth. Now, if you probably on your way out, you discover anybody that goes up and stays up, please run away from that person, because that person did not obey the law of nature. You understand? That body did not. If you see anybody that goes and you are looking at the person up and the person did not come down, then that person must be on the spiritual aspect. You understand? Everybody, human, material, anything that goes up must what? Come down. The only place where any material that goes up doesn't come down is what we call your space. You understand? When you say space, is space somewhere in the universe that's outside this planet Earth. Gravity is not being experienced there. You understand? Human floats in air. You get? You are going to see it in some of the clips I'm going to show you. You see where scientists are floating in air. It means that at that region, gravity is not what being experienced. Now let's proceed. I'm going to show you a lot here. Now, at this junction, that's the theoretical aspect. We are going to be looking at the calculatory aspects too. You have a lot of formulas and a lot of calculations that are involved. Let's proceed. Now, this field extends out in all direction, but the magnitude of the gravitational force decreases as the distance from the object decreases. Meaning that this is the formula for gravity. F equals your G as a big G, your big M, a small m, and a what? Capital G. Meaning that your F remains your what? Force. You understand? Your force of what? Gravity. The G is what we call your gravitational constant. Gravitational constant. Now, if I'm to remove the constant, but don't worry, your big M is what we call the mass of planet Earth. Mass of planet Earth, while your small m is the mass of what? Object. Now, your D is your what? Is the distance apart. Distance apart what? Distance from the what? Object. You understand? To the Earth. Meaning that if this is planet Earth, check it. The distance apart, if the object is here, are you getting it? If this is to be the object, then the distance apart is D here. Now this is the M, small m, and the mass of the Earth is the big M. You understand? Now if I want to bring this back to a normal variable equation, it will be F is directly proportional as product of what? Product of what? The mass of Earth and the mass of what? The body. So meaning that if I want to explain this variation, it means that F is directly proportional as the two masses, and F is inversely proportional as what? The square of the distance apart. So these are the equations. These are some of the foundational equations when it comes to what? Your gravitational field. Let's proceed. Now, a gravitational field is a type of force field and is analogous to what? Electrical and magnetic field. For what? Electrically charged particles and what? Magnets, respectively. Hope you are getting it. So this analysis alone should give you what? A clear background of where we're actually going. This is the fundamental formula, or this is the foundational formula that you're going to be using throughout this course we've started. So just try and sink this into your head. And one thing I need to clear here, if you think sciences, I used to tell some of my students that sciences is not a joking matter. You understand? You want to be a scientist, you want to be an engineer, you want to be a medical doctor, then your brain has to be saturated. When I say saturated, you should be able to what? Swallow a lot. This is one of the smallest formula as regards your proceed. You understand? In engineering, you don't need to be scared. Human beings are there, everybody are there. You understand? You don't need to be scared that if you are must be cramming this is almost the smallest. Now in your mathematics, there is what we call the almighty formula. Then you cramp it now. So if you can, you should be able to swallow this normally and be able to remember it even when you have been woken up at sleep. Gravitational potential. What do you mean by potential? We are talking about gravitational potential energy. You know, so gravitational potential energy. That's what we are going to check it. Now, when we say gravitational potential energy is an energy that possesses, that an object possesses because of its position in the gravitational field. If we recall back to your kinetic energy and potential energy, you know, your foundational physics says that potential energy is an energy with respect to what? Motion. You get? While your potential energy is an energy with respect to what? Your state. You get? Or being static. Instead of being static, that is, potential energy is being experienced with respect to a stable position. You get? While your kinetic energy is an energy that is experienced with respect to what? Motion. That is, while you are moving, you what? Exhibit kinetic energy. As I move from this point to another point now, I'm exhibiting kinetic energy. But if there is anything in my body that is going on, I'm actually exhibiting an energy with respect to the fact that I'm stable, I'm at a point, I'm not moving. That particular phenomenon is what we call your potential energy. Now bringing it back to your gravitational potential energy. So we said it's an energy that an object possesses because of its motion, you understand, in a gravitational field. Now the common use of your gravitational potential is for an object near the surface of the Earth, where the gravitational acceleration can be assumed to be what? 9.8. Meaning that, remember I said the other time, I said your acceleration due to gravity varies. So at that point now it is what? 9.8 meters per second squared. So the value for your gravitational potential, your potential energy, is given as what? mgh. Okay, I'm getting it. Now, since the zero of gravitational potential energy can be what? Choosing at any point, like the what? Choice of the zero of a coordinate system. The potential energy of a height, h, above the point is equal to the work which will be required to lift the object to that height with what? No net change in kinetic energy. So that will give us our what? Value or formula for what? Potential energy. Now, gravitational potential energy. Now, coming back to gravitational, we will now see, look at the expression. It says the general expression for what? Gravitational potential energy arises from the gravity, law of gravity, and it equals to the work done against gravity to bring a mass, you understand, to a given point in space. You understand? Now, because of the inverse square nature of the what? Gravity force, the force approaches zero to the large distance, and it makes sense to what? Choose the zero of gravitational potential at an infinite distance away. Now, the gravitational potential energy near a planet is then negative. You understand? So from here now we can now see our what? Gravitational potential energy will be given as what? Minus Gmn all over what? R. We are told that where our G is our what? Gravitational constant, where the m is the mass of the attractive body. You understand? And your R is the distance between their what?